year 2020. Okay, so let's start with the first question. Which length is the longest? Okay, so if you look at the numbers here, they are roughly the same. But if you look at the units very carefully, they denote different things. Okay, the first one, they're actually trying to show megameters. Okay, second one, kilometers. Okay, third one is just meters, and fourth one is millimeters. Okay, at first glance, it might be very difficult for you to compare easily. Okay, but the technique to answering this question is actually to compare in the same units. Okay, so that is easier. Okay, so if I were to convert everything into meters, okay, A would be actually equals to 2.4 times 10 to the power of 6 meters, because mega means 10 to the power of 6. Okay, B is 240 kilometers. Okay, so it will be 240 times 10 to the power of 3 meters, and I change it to the standard form, okay, which is 2.4 times 10 to the power of 5 meters. Okay, C is already in meters, so no issue. Okay, and the next one, okay, 240,000 millimeters. Okay, so for 240,000 millimeters, when we convert it to meters, okay, we have to be very careful, because instead of a multiplication, it's actually a division. Okay, division by how much? Milli is 10 to the power of -3, so it would be 240 meters. Okay, so if you look carefully, the best answer, you want the longest, okay, the best answer would still be A. Okay, B. Question 2. The diagram shows a pair of vernier calipers used to measure the length of a wooden block. Okay, so if you look at the vernier caliper scale very carefully, we start off with 0. Okay, and we do need to find out where is the 0 on the vernier scale. So this part here is the 0 on the vernier scale. And where is it on the main scale? So if you look at the main scale, it's actually down here, the purple line. Okay, this part. Okay, at this point, you can see that the closest, smallest value is actually 1.2 cm. Okay, but we know that it's in between 1.2 and 1.3 cm, so it will be 1.2 something cm. So how do I find the something? Yeah, so if you look at the vernier and main scale, you find that this particular line joins exactly. So when it joins exactly, we just need to check what is the value. In this case, the value is 4. So it will be 1.24 cm. And hence, the answer is D. Question 3. Okay, the diagram shows a pendulum oscillating between X and Z. It takes 1.8 seconds to go from X to Z. Okay, and back to the midpoint Y. What is the period of the pendulum? Okay, so when we talk about the swing itself, in order to complete one oscillation, the period, okay, you must go from X to Y to Z, back to Y, and finally back to X. But if you look at the question itself, it tells you that from X all the way to Z and come back to Y is 1.8 seconds. So we can actually speed up these parts for this journey into 4 parts. Okay, X to Y part 1, Y to Z part 2, Z to Y part 3, and X to Y part 4. So essentially, okay, the 3 parts that we have, okay, shouldn't put equal sign. The 3 parts that we have takes 1.8 seconds for it to travel the 3 parts. Okay, the 3/4 of the journey. Okay, but now I need to find the total, which is the 4 parts of the journey. So for those who are unfamiliar, you just need to divide by 3 first. Okay, then multiply by 4. So 1.8 seconds divided by 3, multiply by 4. Okay, and if you done it correctly, your answer should be 2.4 seconds. Hence, answer is C. Question 4. A sports car increases its speed at a constant rate. Okay, take note, increases speed at constant rate for 1 minute. The diagram shows the car, which distance time graph shows the car's motion. Okay, so we know that based on this question, okay, they say that it's speed. Okay, so if you talk about speed time graph, it will look something like this. Increases at constant rate. So it's actually a straight line graph or the speed time graph itself. Okay, but if we convert this into the distance time graph, okay, then we need to show that the gradient of the speed of the distance time graph actually changes, because you can see that the time, for the increase in time, the speed actually increases. So this would essentially mean that I need to show that the gradient of the distance time graph must change. Okay, so when I say it must change, okay, it can be in this way, or we can say that it changes this way. But at the moment, we don't have any definite answer. It should be either one of these. So let's look through the answers that are available. For A, okay, it's a straight line graph. If I calculate the gradient, this is a constant gradient, which will not give us our answer. Okay, for D, it will be similar situation. Okay, for B and C, let's check carefully. B, you can see that the gradient actually increases over time. But for C, the gradient actually decreases over time. So therefore, in this case, B is our best answer. Question 5. A submarine of mass 1000 kg sinks in water at a constant speed of 2 meters per second. What is the resultant force exerted on the submarine as it sinks? Okay, so when you talk about this, okay, you have to be very careful, because when you talk about sinking at constant speed, okay, the word constant speed actually denotes there is no resultant force. Okay, so do not be fooled by the question. Okay, so answer for question 5 is just A. Which property of a body resists a change in state of motion? This one you just need to memorize. Okay, so when we say a body resists a change in state of motion, we are trying to talk about inertia. Okay, so mass is the only property of a body that is related to inertia. Question 7. Down here, they show two objects that are made from the same material. Sorry, they are asking which two objects are made from the same material. So you will notice that they give you mass and volume. Okay, so this allows us some understanding that we need to calculate density, because density of the same material, it would be the same. Okay, so if the objects have the same material, they have the same density. Okay, so we need to calculate each one of them to find out which one would give us the best answer. So density, the formula is mass over volume. So W, the density. Okay, if I were to create another column, okay, W, the density, look like this. Okay, 10 divided by 2, which will give us a 5. 10 divided by 4 is 2.5. Okay, 20 divided by 4 is 5. And 20 divided by 2 is 10. So you notice that for density, W and Y are exactly the same. And therefore, the answer is B. Question 8. The mass of a boy is 50 kg. The gravitational field strength is 10 Newton per kg. And that on the moon is 1.6 Newton per kg. which statement describes the weight of the boy? Okay, so take note, they're talking about weight. Okay, mass of the boy doesn't change because it's a constant between the situation on Earth and on the moon. But you notice that the gravitational field strength actually changes. On Earth is 10, on the moon is 1.6. Okay, so when we talk about the weight of the boy, okay, let's go by elimination. The weight of the boy is the same on the Earth and on the moon. This is not true because if you follow the formula, W equals mg, okay, and substitute in the weight of the boy on the Earth is 50 multiplied by 10, which will give us 500. The weight of the boy on the moon is 50 multiplied by 1.6. Okay, which will not give us 500. Okay, so it's definitely lower than 500 newtons on Earth. So A is out of the question. Okay, the weight of the boy on Earth is 50 newtons. As you see what we have calculated here, okay, it is not true at all. Okay, the weight of the boy on the moon is 50 newtons. So if you look at my second step here, you know that it is definitely wrong because 50 times 1.6 it is not 50. Okay, it will actually give us 80 newtons. So the answer is actually D, 80 newtons. Question 9. The uniform bar is pivoted as middle. Okay, what force F is needed to balance the bar? Okay, so if you remember this particular chapter, we are talking about the principle of moments, which means the clockwise moment must be equals to the anti-clockwise moment. So let's put in all the clockwise moment and anti-clockwise moment into the equation here first before we actually proceed. So if you look at F is going to give us a turning effect of this direction, which actually fits a clockwise moment itself. So force times 3, this will be equals to the other side, the 6 Newton will give us an anti-clockwise moment. We should give us this. So force. So after the first step is actually just mathematical calculation from here on. Okay, so I'm showing every single step here. Okay, final answer is 8 newtons. Okay, so always set up your equation first before you actually proceed on. Number 10, an empty eggshell that has molten wax solidified inside, as shown in the figure. Wax is denser than air. Okay, so the egg was then placed on the flat top and allowed to rotate freely, which correctly shows the resting position of the egg on the table. So if you look at the way that the wax has been solidified, it is occupying the narrower part of the egg itself, which means down here it has more mass than the hollow region. Okay, so this actually will create a shift of the center of gravity. So the other time we talked about this before, the center of gravity, if it's here originally, okay, it will then be forced to move closer to the wax itself because the wax is the heavier of the two things. Okay, so having said that, if you look at the answers, A will not be true, B will not be true, C will not be true, D is the most likely answer. Okay, because once the center of mass or center of gravity shift towards the wax itself, it will actually try to balance itself over there. Okay, while on the other hand, A to C, they are actually in unstable equilibrium, and therefore they will try to go towards the position shown in D. Question 11. A student of weight 700 Newton has a contact surface area of 0.5 meter square with the ground. What is the pressure exerted by the student on the ground? So we know that pressure is force over area. Okay, so let's substitute in 700 divided by 0.5 because that is the contact area that is shown. Okay, so if you've done it correctly, your answer from here is actually 1,400 400 pascals. Therefore, answer is D. Question 12. A ball is dropped from a height as shown. Ignoring the effects of air resistance, state which statement correctly describes the total energy at each point. Oh, be very careful. They ask for the total energy at each point. Okay. And if you know your things very well, at the start we have potential energy, at the end we have kinetic energy. Okay, and we are also compelled to use the conservation of energy. When we talk about conservation of energy, remember there are a few things that was mentioned. Okay, first, that energy cannot be created or destroyed. Second, energy can only be converted from one form to the other. And lastly, the total energy is the same. So hence, the answer is D. Question 13. An electric lift can carry a load of 10,000 newtons up a height of 20 meters in 30 seconds. You are asked to find the power. So we know that power equals to work done divided by time. And work done means force times distance. So in this case, the force is 10,000. The height, which is the distance here, is 20 meters. And divided by the time, 30 seconds. Okay, so if you have done it correctly, okay, you should be able to get the answer as this value is 6,700, which means the answer is B. Number 14. Okay, the diagram shows the arrangement of particles in substance at two different temperatures. Okay, which would represent the diagrams shown. Okay, so if you look at the 178 degrees Celsius, this is definitely showing a gaseous state. Okay, at 100 degrees Celsius, this is showing a liquid state. But what's the difference between a liquid and solid? You notice that in these areas here, there's still some space in between the particles. Okay, unlike a solid, okay, if I were to draw a solid, it will be shown in this manner where the particles are actually touching each other and show a fixed regular pattern. Okay, so solid will look like this. Okay, so having said that, we can now say that the melting point and boiling point, okay, from this particular question, okay, the boiling point must be here in between the temperatures of 100 degrees Celsius and 178 degrees Celsius. Okay, so if you look at the answers that are given, only B would satisfy that condition. Okay, the rest of the answers doesn't. So which means B is my best answer. Number 15. Four identical cans A, B, C, and D have their outside surfaces painted either dull black or polished silver. Okay, each can contain the same amount of water at an initial temperature of 80 degrees Celsius. Okay, so after 5 minutes, okay, what in aircon room? Okay, which one will have the lowest temperature? So if you look at the question itself, it's actually talking about the idea of radiation. Okay, and when we talk about radiation, in this case, we are trying to talk about losing heat. Okay, because it's placed in the aircon room, so we are trying to make it lose heat. Okay, make the water lose heat. So we are talking about a emitter. Okay, and we know that for emitter to be the best, okay, it must be black, dull, and rough. Okay, so these are the kinds of emitter that we want. Okay, that is very, very good. Okay, so if you look at the question, dull black, this is okay. Polished silver for B is not okay. But for C and D is very similar, but the problem that is that there is a lead. So the lead actually reduces the convection current, okay, the heat loss by convection current, okay, and therefore, if I talk about the lowest temperature, A would be my best answer. Question 16, which correctly shows the difference between boiling and evaporation. Okay, so let's check through the differences, okay, and see whether any of them make sense. Okay, bubbles are seen for boiling. Yes, that's true. No bubbles are seen. That's true as well for evaporation. For boiling, it occurs at any temperature. This is not true. Okay, in fact, it's the other way around. Okay, for evaporation, it should occur at any temperature. Okay, for boiling, it does not occur at the surface. It occurs throughout the liquid. Okay, on the other hand, evaporation, it occurs throughout the liquid. Okay, and lastly, it's also not true because boiling is actually the fast process and evaporation the slow one. So answer for this is A. Number 17. The diagram shows the trace on the digital display machine, okay, when sound is produced. There are 3 horizontal lines shown on the screen. Which of the following shows a louder sound of a lower pitch? Okay, so be very careful. They talk about louder sound, lower pitch. Okay, so when we talk about louder sound, we are actually looking for larger amplitude. Okay, so let's tackle this part first. So using the 3 lines as the guide, you can see that A, B are not correct anymore. Okay, for the second condition, lower pitch. Lower pitch means less wave seen. Okay, so less waves on the screen. So in this particular case, I have a 1, 2, maybe I use a different color so it's easier to see. 1 complete wave, 2 complete waves, and a half. Okay, so I must have fewer waves than 2.5 complete waves. So if you compare carefully, C will actually be our answer. Okay, because C has 1 and a half complete waves. Okay, compared to D, which has more. So answer is actually C. Number 18, the ship sends a pulse. The ship sends a pulse vertically down. Okay, an echo is heard 0.4 seconds later. The speed of the sound in water is 1,400 meters per second. So if you can't visualize what is happening, don't be afraid to draw a simple diagram to help yourself visualize. Okay, so in this case, the ship sends the echo downwards when you reach the seabed. Okay, we know that the speed of the sound in water is 1,400 meters per second. Okay, we know that for the time, okay, I use a different color. Okay, the time for the sound to travel from the boat to the seabed and back up, the time is 0.4 seconds. So having seen this, okay, let's assume, because they're asking for the depth of water, let's assume that the depth of water is called D. So essentially, the sound have to travel, okay, essentially the sound have to travel from the boat to the seabed and back up. So in terms of the distance completed by the sound is actually 2 times the depth of the seabed. Okay, and divide by the time t, which is 0.4 here. So let's substitute in the value 2d divided by 0.4. Okay, so let's make d the subject of the formula. So it will be 1,400 multiplied by 0.4 divided by 2. Okay, so if you have done this correctly, the number here should be 280 meters. Answer should be A. Question 19. Okay, this one is an electricity question, the chapter of electricity, sorry. Okay, so you have a voltmeter that's connected across one resistor. Okay, and there's a light bulb and another resistor in series with the first one. So this is actually a circuit that is in series. Okay, so this is a series circuit. Okay, so they ask you for the potential difference across the light bulb. Okay, so how do we actually move on from here? The key is actually this, because they say that the two resistors are actually identical. So that means that if I were to put another voltmeter over here, okay, this is actually also going to be 1 volt because they are identical. Okay, and on top of that, the current flowing through them is all the same. Hence, the second resistor would behave the same way as the first one. So now that we know that the EMF is 6 volts, okay, and the individual resistors, okay, is 1 volt each. Okay, now we can find the voltage of the light bulb. So the sum of all the potential differences across the components is equals to the EMF. So once we are clear with that, okay, it is now time for us to work out the value. So voltage of the light bulb is equals to 4.0 volts. Okay, so answer is C. And last one, which piece of copper has the smallest resistance? Okay, we talked about this before. Okay, using the McDonald's straw. So if I want smallest resistance, I want it to be short and I want it to be fat. Okay, short and fat wire. So if you compare all the answers there, okay, the only one that is short and fat will be D. Okay, and therefore the answer is D. Okay, so thank you.